So here we go. Earlier. Okay. I hope you can see my screen. Okay. So in the previous sessions, yeah, welcome to Golang. This is going to be the fourth session, I guess. Okay. In the previous sessions, we discussed about features of Go, installation, configuration, configuring Go, and then we also looked into the compilation part of Go. We had gone through compilation and several details of Go. After that, we had gone through some environment variables which are very much required in Go. We also looked into Go install and stuff like that. Did some documentation in README file, and we were discussing about variable declaration, variable creations. I think in the last session, I was explaining about room characters, which is analogous to int30. I think 1 minute. Okay. So analogous to int32, and then there is a byte which is analogous to uint8 and all the things we were discussing. Okay, character is always 4 bytes in latest programming languages that support Unicode characters. That we already are aware of that. These are all the data types actually. Byte, character, integer. This is a alias. This is how you can create an alias to existing variable. Right. Now we go to the next section of variables. What I do is mkdir variables, three variables. The first step is I have to do go mod init. I just give demo and then code main.go. As I said earlier, if code is not found, uh, if code is not found, sorry, if code is not found in your system, uh, how you have to do, go to command palette and then type code, shell command install code command in path. It installs the code command and then just you can type code here. Automatically the file get created. Otherwise you can go right click on that and then create your own file. Package main, function main. We have also observed that it's not necessarily to be everything in one file. You can split it into multiple files. Somewhere in one of the examples, we did this, greet and then hello, and then somewhere we called greet as well. You can split the main into many files. And one more thing is, it is not necessarily the name should be main.go. It can be any name, relevant name. If you are creating a server, it could be server or service or whatever the name it is. But package, if it is a binary project, then the package should be main. That's very, very important. Now, uh, we go for conversion actually. We talk about typecasting or conversion. One of the very, very important aspects, typecasting or go conversion. Generally, in many programming languages, if you talk about Python, actually, you don't need to even specify a type. If you create a variable, you can give any value or to that particular variable. You don't even need to give a type. But generally, for many programming languages, including C, C Sharp, and Java, there is an implicit type and explicit type. The implicit typecasting and then explicit typecasting. What is typecasting? A type is converted into another type, which we call it as a typecasting. Definitely, you cannot convert each type to any other type, which is not possible. You cannot convert uh, different types to same type. You can create a boolean and then you try to convert to integer. It is not possible in Go. Boolean is different altogether. Integers are different, but you can convert numbers of any type can convert numbers of any type, cast numbers of any type to numbers of any type. What does it mean? Numbers of any type means numbers int and then int 8 to int 64, int 8 int 16 32 64, and then int 8 to int 64. These are all f full 32 and float 64. These are all numbers basically. Even decimal points also called as numbers. That's all. So numbers can be converted from one type to the other type, but not implicitly converted. There is absolutely nothing in Golang that something can be implicitly converted. There is absolutely nothing. Again, type aliases are different. You are talking about type alias here. Okay, type alias converting there, you don't need to convert to into integer because both of them are equal, same. But one type to the other type, whenever you are converting one type to the other type, you have to convert, but it is not implicitly converted. If you look at actually C# program, for example, there is long, maybe number 1 equal to 0, and then you have something called int, where maybe you have anything called short number 2 equal to some value. Okay, num1 equal to num2. This is possible in C#. There is an implicit typecasting because long is a very big number, 8 bytes. Short is, I think, 16, 2 bytes. What is it? What does it mean is 2-byte number can easily be converted, casted to 8-byte number. So 2-byte number, this number can easily be converted to 8-byte number, which is implicit typecasting. But Go doesn't support implicit typecasting. Any type in Go, it has to be explicitly casted if you want to convert one type to if you want to assign a value from one type to the other type. Let's say that I create something called same thing, where num1, which is of uint 8 equal to some number. You can create multiple variables, right? Num2, which is of uint 64 equal to num1. This is not okay in Golang. It's not okay. Okay, there is no implicit typecasting in Go. So you cannot convert, even though this is small and then small number can easily be fit into big numbers. What you have to do, you have to typecast it. How can you typecast it? Num2, which is uint 64 equal to the type to which you want to convert should be like a function actually. So int 8 variable should be converted. So what is the, it is not a function, but you can think of a function. Generally in other programming languages you do typecasting like this, but in Go you don't typecast like this. This is like a function. It is not a function, but it is like a function. int 64, you are converting, this is called typecasting, converting a type to another type, which is called typecasting. Okay, you are converting num1, which is of uint 8, is converting to num2, which is of uint 64. This is called typecasting. Okay, you can typecast like that. Sorry, just printing it. This is called typecasting. You are casting one type to the other type. Cool. Okay, let's take another example. Let's take another example. I take a variable which is num num3, which is of int 64. Let me put it as uint 64 equal to some number. I would like to convert num4 is uint 8 to, you want to convert typecast this number to this number. So how do you typecast? Uint 8, it become like a function, again I'm not telling that it is a function. Num3, you are typecasting a big number, 8 bytes, or trying to fit to 1 byte. This is very important, and then you get a lot of information about that. This is fine, there is no problem. Uint 8 is converted to int 64, nothing you're gonna lose. But here there is a problem. You are trying to convert 8-byte number into 1 byte. If you take this number, okay, if you take that number, let's say, what can I do? Decimal to binary 8 bytes, convert to decimal to binary. I give a decimal number. This is only, I think, how many bytes? This is only 32-bit. That's fine. Sorry. So what you're gonna do here is you are converting. This is the 8-byte number. Here it is taken as only 4 bytes, but okay. 8-byte number, basically there is no problem even it is a 4-byte or 8-byte, but because we are converting only to 1 byte, this is the number. If you try to convert this number to uint 8, what is converted is, because uint 8 is only, num4 is only 1 byte, so what it does is exactly 1 byte from the right side, it could be converted. That means 1, 2, 3, 4, 5, 6, 7, 8. This is the number. You see that binary to decimal, I give a binary number. 255 is the number. 255 is the number that got converted. Okay, 255. So go run main.go to see that 255 got converted. Why 255 you got? Let us say I give another number. This is the number. Let me put it as decimal to binary. This is the number I convert. When I convert it, this is the number. Let's take 8 bits, because you are converting 8 bytes to 1 byte. 1, 2, 3, 4, 5, 6, 7, 8. This 8 has to be converted. Let me go to binary to decimal. I give the binary number converted. 201 is the value. You got to get the unsigned, because I purposely gave unsigned. If it is a signed, then it's a different calculation. Unsigned is 201. 201. Same way you give num5, which is of u int 16, equal to, you want to convert u int 16 of num3. For example, I want to convert print line num5. It's not like randomly convert. You may think that how does it convert? How does it put 8 bytes into 1 byte? It doesn't do randomly, but it does very, very gracefully. There is a binary operation happens for this particular typecasting. Let's say it is 16-bit, unsigned 16-bit. That means 2 bytes you have to take. So what would be the 2 bytes? If you go back to your previous number, okay, let me copy this number. If it is a Rust, it gives even the number in binary format. It's a decimal number. It got to be converted to binary. I said 2 bytes. That means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. This is the number. It gets converted. Go to binary. I go to decimal. I copy the number. 50121 is the number. 50121. Whenever it is converted. 50121. That is how the typecasting happens from bigger size variable, the value variable which has got a big size, which get converted to a small size. What if I have only 125? Then it's pretty simple. 125 is only copied, because 125, even though you are saving it in uint 64, 125 will have, it has got all zeros basically. If you look at 125 binary, you see that if you put 16 bits, all are zeros. 1, 2, 3, 4, 5, 6, 7, 8. After that, all are zeros. 1, 2, 3, 4, 5, 6, 7, 8. All are zeros. So even if it is 64-bit, all are zeros. Only 1 byte is converted, that 1 byte or 2 byte converted as it is. So it's all about bitwise conversion. And you can also convert from float 1 as float 32 equal to some number, and then num6 is uint 32, maybe uint, yeah, 32 is fine, I guess, equal to, you want to convert uint 32 of float 1, only the decimal part would not be converted, only the binary part is converted. Print line num6, which is you are converting, num6 only the decimal part is converted. If it has to be converted to a smaller size, then again that decimal part is taken and then it gets converted as a bitwise conversion. Okay, that's what it does. But however, this is what the decimal part is converted. Okay, that's what it does. But what if I create something called a variable? Let's say, okay, one is boolean equal to true. What is the size of boolean? 1 byte. I want to convert it to, okay, let it be uint 8. Num7 is uint 8. equal to int 8 of OK1. So you cannot convert non-new numbers to numbers. You cannot convert non-numbers to numbers. The reason is OK1 is not a number. You can go and write a logic if OK equal to true, you can go and write if else logic, If OK1, okay, let it be number 7 is 1, okay, then you can write else number 7 is 0. That's a different thing. That's a different thing. Okay, I think you should not write over here. You just have to write over here. That's a different thing altogether. This itself is wrong. This is a different thing. But as a conversion, you cannot convert. Okay, one is a Boolean type. A Boolean type cannot be converted as integer. Boolean is it's not, it doesn't belong to numbers. Only numbers can be converted to numbers. That's very, very important. Okay. Okay. It doesn't happen. It doesn't happen. Okay. So Boolean cannot be converted in fact to any type. Boolean cannot be converted to any type. Logically, you can write if OK1, that means OK1 equal to true. This is nothing but OK1 equal to true actually. This is nothing but OK1 equal to true. That's a different thing. But as for typecasting, I am telling. Okay, I'll ask you a simple question. Byte 1 is byte equal to some number. Okay. Now, num7 equal to int 64. Can I convert byte 1? Can I convert or not? Is my question. If you are on mute, actually, you can unmute and tell me. Can I convert it or not? I can't hear anything. I don't know. Neither you are able to. Okay. The thing is that you can convert. The reason is byte is nothing but uint 8. So uint 8 is nothing but because byte is an alias for uint 8. If you look at byte is an alias for uint 8 and then equivalent to uint 8 in all ways. In our last session we discussed. In any case, every case, byte is nothing but uint 8. It's not a separate type. It's uint 8. But the alias name that in our previous session we created some alias for integer, character and or similarly, it's an alias for integer, uint 8. So it can be easily converted to byte 1. There is no problem. Just that I have to print it. So I create one more type which is called rune1 equal to some Chinese character. Uh, Okay, I just think that this is a Japanese character. I copy this character from Japanese. I give this character. I put rune. It's not run, it's rune one. I put it as char one. Okay, let it be. Can I convert it to int64? Can I convert it or not? I can convert this as well because rune is nothing but int32. It's not a separate character. Rune is nothing but int32. You can see that in all ways it is int32. So int32, since it is int32, it can be converted. So it is seamlessly converted. Okay. So I think you are clear now what can be converted and what can be casted or what cannot be casted, which is called typecasting in Go. So no type can be automatically or implicitly converted to the other type in Go. So each type is a separate type. Okay, each type, unless there is an aliases are different, but each type is a separate type. You cannot convert one type to the other type implicitly. Certain types you can convert. You just need to have that sense that you cannot bring a boolean and then try to convert it to integer. You cannot bring some maybe user defined type and then try to convert it as an integer, which is not possible. Numbers of any type, as we said, uint 8 to uint 64, int 8 to int 64, float 32 and float 64, any type can be converted to the any type. Okay, there is absolutely no problem in Go. In fact, there is also a type called complex type. C1 equal to, there is also called complex. Complex types are real number and imaginary numbers. I think complex types are used for mathematical and scientific calculations. I think so. Real number and mathematical numbers. Complex type. There is a built-in function called complex. If you give a real, if you give a real number and then if you give a imaginary number, if you give a real number and then if you give a complex is a function, if you give a real number and then if you give an imaginary number, you can create a complex number. C1 is a complex number. But C1 could be complex 64 or complex 128. It depends on what values you pass to complex number. It is kind of a maybe factory kind of a thing. This function complex, it returns two types. It's not always return one type. This is a validated compile time, but it can return two types based on what we pass here. If you don't pass C1, okay, you see that C1 is complex 128. Let us say that I say R1 is float 32. Okay, I'll create where R1 and then I1 equal to float 32 of 12.2 and then some number. I have R1 and I1. Now I create C2, say shorthand declaration, complex of R1 comma I1. If you see that C2 is not complex 128, C2 is complex 64. C2 is complex 64. C2 is not complex 128. C2 is complex 64. The reason is both the parameters R1 and I1 are of type float 32. Since R1 and I1 are of type 32, this got to be the complex. C2 is a complex 64. You can also perform arithmetic operations on complex. Of course, you can perform arithmetic operations on uh, anything. Let's say C3 equal to, it's a new variable, left hand side shorthand declaration, C1 plus C2. But the problem is C1 is of one type and then C2 is of another type. So I can convert complex 128 of C2. I can typecast it. If you look at C2 and then C3, C3 is a new type which is a combination of arithmetic operation of arithmetic add of C1 and C2. We can have something called C4, which is a, I write like this, where C4 is complex 64. Interestingly, I write like that, equal to complex 64 of C1 minus complex, you don't need anything because C2 is already complex 64. C1 is complex 128, so you convert it as, because the left hand side is of complex 64. Even you can do uh, multiplication as well. I think complex, I'll just give C5 equal to C1 into C1 into complex 128 of C2. You don't need to write complex numbers. Is there, like, directly you can write a complex number like this as well. Some number plus some number I. C6 is a complex number. How it is a complex number? Because the plus operator and then I, it is a, C6 is a complex 128 number without complex function can create a complex number with shorthand declaration. Real number plus imaginary number is a complex number. Just print all the numbers, print line. For now, I'm just giving C1, C2, C3, C4, C5 and C6. Just printing it, otherwise it take you error. All the numbers are printed over there. If you want to format it, you have to properly format it with a format package, fmt dot. So always format package is user friendly formation it does. Okay. So I don't know how the multiplication work on complex numbers, but addition and subtraction are, the real part will be added. Let's say this is, you want to do addition of these two numbers, the real part of 12.123 and 123.234 is added and the imaginary part gets added. That is how the addition or subtraction, multiplication, I don't know, I think how it uses some mathematical formula to do the complex number multiplication. And this is also a complex number, as I said earlier. It's a shorthand declaration for complex numbers. We are also converting or typecasting these complex numbers. Okay, this is what actually about the basic typecasting. We have yet to go a lot with this. This is a basic typecasting uh, in Go. Let's go to the next step. I'll create another example. Mkdir variables. Go to that. Go mod init demo. I just give the same name. In fact, that is not you. I need to give. You need to give the proper module name. Code main.go. It creates a main file. Package main. Function main. Cool. Now I have a value which is of string. This is the value. Val1 is of type string. I want to convert uint32 to uint32 of val1. Here, technically, which is not possible because val1 is not an integer type. Val1 is a type of string. So, string is not necessarily to be an integer. You can have any number, any kind of characters over here. So, technically, this is not possible. But what if you are getting data which is of really integer or float, but you are getting data in the form of you are getting data in the uh, you are getting data in the form of string, then how do you do that? That's very, very important. For that, you go to a package called uh, you have a package called string strconv, which is a very, very famous package. Strconv is the package. String conversion. This package is pretty useful package, in fact. Strconv. So what do? You go here, you say import strconv. Whenever you declare a package, it is must that you have to use the package. If you don't use the package, the IDE, the Go language server, the IDE, whatever the IDE that you are using, if you save it, because it is not saved, you see that the white color circle or sphere, whatever it is, it is not yet saved. When I save it, the Go language server will automatically delete it. Okay, if it is not a Go, I put it as a text, then it will not delete. But when you try to run your application, you don't see any kind of help from this IDE because the IDE thinks that it's a text file, it's not a Go file. Okay, when you run it, you get a lot of errors. Number one is strconv has declared imported but not used, and then val1 or num1 is declared but not used. Uh, strconv imported not used, declared and not used, which is called num1, cannot convert var1 to a type uint32. There are three errors. It's a compiled errors. How you are not how are you solving these errors? Basically, if it is a Go tool you are using, whatever the tools that we have got that are running along with your Golang, how do you know the tools? When you go to command palette, we say install update tools. We saw in our last session, everything gets installed into the Go bin directory. You see that GoPols, which is a language server. This language server and static check linter, these two help a lot for your. It helps your IDE a lot. It helps your IDE a lot. The whole IDE work on all these tools are important. This is for the debug purpose. This is for the tags. One is for the tests and all. But these two are very, very important actually. Earlier there were around I think 11 tools, but everything got into 7 tools. Fine. So any package that you declare, if you import, it has to be used. If you don't use it, let's say that you want to import but you are not going to use immediately. What you can do is you can put a blank identifier here. Blank identifier is very important in Golang. Uh, Go has uh, Go uses blank identifier a lot actually. We will discuss about that even in the next example. However, I'm going to use this. So if you save it, it would be gone. But what you can do, this is not possible. But what you can do is where num1, which is of int 64 equal 64, the string conversion package strconv has a function strconv dot string to integer a to I. I assume always for me a to I and then I to a. There are two things. For me to remember, I think I put ASCII to integer and integer to ASCII. I don't know exactly a to I to a, but the function names are a to I. A to I is equivalent to parseint. This is equivalent to parseint. You see that parseint. This is based on okay. However, a to I. A to I means ASCII to integers. What is the ASCII value which is in a string called val1? I want to convert it to integer. It is not integer. I give it as int64. Okay, let it be for now integer. We will see later on. num1, comma. This function, if you really look at it, this function returns two arguments. This function doesn't return one argument. Functions in Golang can return more than one return type at a time. More than one return type, Go functions can return any number of arguments as long as there is a stack size. You can even return 10 arguments. A to I function return two arguments. Number one is if it successfully converts, which is going to be the number, which is called int. If it doesn't successfully convert, it is going to return an error. So instead of an error, because if there is an error handling even in the first session we discussed, error handling in Go is quite different. Okay, the reason is errors are just like values in Go. Okay, if you want to return an error, there is no try catch block kind of a thing where the catch block can automatically pick errors. It's not like that. You have to handle errors by yourself. Errors are just values. So if A to I is unable to convert val1, there are many cases why val1 cannot be converted to int. Maybe there are some characters in that. Maybe somewhere there is a character. That means it is not an integer that to convert. It cannot convert. For that purpose, it returns an error. Right now, we are not doing anything with the second argument, which is called error. So we can put a blank identifier. Let us say this is int 64. What happened? This is coming as num1, but it is converted to int 64. You cannot convert directly. You cannot go and then put it as. So here, that's the reason what people does is they do like this. Shorthand declaration. The reason is the function is going to create two variables. Function is going to declare two variables. You cannot have one variable. It's two variables. The second variable I'm not going to use, so I put it as a blank identifier. Blank identifier has a lot of importance. Okay, it's very imperative in Go. We'll discuss about that because many times function return more than one value. So we may not be using more than one value for each and every function. We may not be using. At that time, we can simply call blank identifier. Okay. Assuming that it has converted, this can be done only if it is successfully converted. Remember that. If it is not successfully converted, it cannot be done. So value is 12312 and then it is of type int. That means this val1 has been converted to num1. So what if I have something called a character over here? What if I have a character? Then it cannot convert. Value has given 0, type is int because it gave the default value. But 0 is also a value, so you cannot, based on 0 you cannot do. This case, you cannot, based on 0 you can do, rather you really have to use error. What you always have to do, if error not equal to nil, there is no null in Go, there is only nil in Go. Else, so what does it mean by error is not nil? Error is not nil means nil. There are some variables which has got data, which has got something called nil. You can check nil with some variables. Some of them are like slice, map, pointer, interface, channel. These you can check whether something is nil or not. I will discuss about this later on. Just telling you, we didn't discuss about if, we didn't discuss about nil and all, but just giving you some example here. What if val2 cannot be converted? If it cannot be converted, I just print the error. If it is converted, it gives the values of this. But we know that it cannot be converted because 1 to A is there, it's a character. If a number has got a character, it cannot be converted. If you look at it, it got an error called parsing 112A312. It got an error called invalid syntax. The upper one got perfectly converted. Okay, this is how you have to convert a string to integer. Okay, we have something called strconv dot parse float. Parse float, you can give parse float is also there. Okay, so parse float converts the string s to floating point number with the precision specified by bit size. If you give as 32 for 32, 64 or 64, let's say I have got a string, let's say where I'll give string val3 equal to, this is the string, strconv dot parse float val3 comma 32. So it convert Here this is only bit size, but however it always convert to float 64 only. So float 1 comma error. Yeah, forget about error right now. Float 1, because we know that there is no error here, but fine. For some time keep an error aside. So fmt.print line value equal to float 1, and then type equal to, there is something called reflect dot type of, there is also, you can use like this, float 1, there is something called reflect dot type of. Reflect dot type of also, it's a reflect package. It gonna get you the type of. Otherwise you can give post printf and then percentage %t also can be given, but here I gave it as reflect dot type of. We're using parse float, that means a string we are trying to convert to parse float, float 64, this one. Actually it took more than what we are supposed to give. You see 123046 or something. I think we have to control it with printf. I don't know, when I give 32, parse float converts the string s to floating point number with the precision specified by bit size. So 64 for float 64, when bit size equal to the result still has the type, but it will be convertible to float 34 without changing its value. Okay, that's fine. That means even though you give 32 or 64, it always gives in 64, but you can convert it without losing the value, because the value will not be lost if it is really float 32. And this is the documentation about this. Fine. Like that, you can have parse bool as well. Okay, val 4 equal to true, strconv dot parse bool. Parse bool is very very interesting. It not only gives the boolean, it also checks what all you give. Even if you give 1 t 2 3, I mean 1 small t capital T true, true capital true 0, again for false 0 f, everything is given as false. I think they would have added yes or no as well. Fine. True, I give it as false bool. There is only val 4, okay 1, blank identifier, okay 1, okay 1. So true boolean. What if I give at 1? Even it give it as true. What if I give as capital T? It's true. S is doesn't work. Otherwise it would have been good as well. It give it as false, because S there is nothing. So whatever you give else, it gives false, because it is ultimately boolean and the boolean result is always false. But you have to use the error as well. For example, if you enable error, it gives an error. Whatever the data you give is invalid syntax. But here we are not checking error, so always it gives false. If you give 1, if you give capital T, also it gives as true. This is all parse bool and all. These are all things that convert. What about you convert from int to string? strconv dot parse int to string. Let's say where num1 Maybe num1 is already there. I give num2 equals some number. It is taken as integer. Oh, redeclare. That means I give num3. Okay. Now I want to convert. Again, you have two options. One is called strconv dot a to I. Similarly, there is I to a, I to a, integer to ASCII. Now there is no problem of error because however the number is the number, it always be converted as string. Val5 is a string. You see that val5 is a string. It can be converted. It is always a string. But the best way people how they do is they use something called fmt dot sprint. Sprintf is one of the best functions to convert anything to the string. Okay, if you see this, we have OK1 which is of a bool, we have float1 which is of float, and then we have number1, right? You see this, number1 is percentage d and OK1 is a percentage v. I give uh, float1 is percentage f. I give, and then OK1 is percentage v. I give. That means v is given. I give as num1 comma float1 comma OK1. Everything can be converted into string like a formatter. This is okay. Val6 equal to everything can be converted as string. So a sprint is pretty good function than anything else. If you want to convert anything to string, any data that is there, you can convert it into a string. You say I don't want all this, I just want only the integer num1 to be converted as string. Fmt dot sprint of num1 val7, it is converted to string. If you want a combined data with from the different fields you would like to convert, you can do that using this one, sprint. Sprint is a very important function that converts the use. Everything got converted as like this, like a formatter. You might have seen something called format in other programming languages. That kind of format you want, you can use something called a sprint. I think there is no format. There are format string. There is format string. Or we can say verb, reun and all. I don't know. I never used format string. Returns a string represent fully qualified formatting. There is something called state. It's quite seems it is quite lengthy process. But a sprint is pretty simple. You give any data that can be converted as string. That's what the sprint is all about. Okay. So this is what actually for now. Let me add everything to the git add status. Git add demo variable. I think I have to rename it. Add four variables. Git commit. Add more examples. Git push, gets pushed. The repository, I already gave the repository. Okay, if you don't know where is the repository, hub.com. This one, this is the one, this is the repo. Okay, you can go to that repo, get your examples. Okay, this is what for today. Tomorrow we'll go into uh, more in depth. Okay, there is something called any, which is an empty interface, which is very important in Go. Even before uh, generics, before version 1.18, it is used everywhere. But now people started limiting that particular feature. But any is very powerful, very useful. We'll look into that in tomorrow's session.